What does the SSPSF model, dropping of sand grains in a sand pile, and the triggering of neurons in a network have in common? The idea of avalanches. In particular, SSPSF stands for stochastic self-propagating star formation, a proposed mechanism in the late 70s. This involves the concept of massive stars producing new star formation sites when they explode as supernovae. These new star formation sites in nearby regions can create a possible chain reaction of star formation events. The SSPSF mechanism was first modeled using cellular automata or CAs. A CA is a discretized model defined by a finite grid composed of cells having states, neighbors, and a set of rules that govern the interactions of cells over time steps within the grid. In the case of the SSPSF model, a 2D polar grid of equal area cells undergo the following processes in every time step: differential rotation based on galactic rotation curves, stochastic neighbor triggering dependent on the stimulation probability and the refractory time to create new star formation sites, cell aging, and spontaneous triggering of a small number of cells for the stabilization of the model. With these in mind, the objectives of this study are to reconstruct the SSPSF model Gorilla and Sidon created, and to observe the chains of star formation events that occur within the simulations. Additionally, this study also tries to explore some conditions within the SSPSF model that possibly exhibit criticality. Criticality is one important subject matter in physics. A practical example of this phenomenon could be explained by percolation theory. Close to the critical percolation probability, the mean size of the clusters or shaded regions diverge, implying scale invariance or non-characteristic definition for the mean cluster size. These invariances are represented by power law distributions, and these power law distributions also arise from other systems that exhibit criticality, such as the avalanches in sandpile models and neuronal networks mentioned in the beginning. In summary, the following criteria were adapted to determine possible criticality, namely multiple power laws, an exponent relationship between the power law exponents, the observation of a phase transition, and the collapse of growth profiles into a similar shape when scaled down defined by a universal scaling function. Using the model parameters Girola and Sidon implemented, the star formation, chain size, and duration distributions obtained showed subcritical behavior. However, varying one of the model parameters, particularly the refractory time, the star formation, chain size, and duration distributions showed a phase transition from the subcritical to the supercritical phase. This implies a possible critical state somewhere in between, and further analysis was done to the chain size and duration distributions of suspected critical behavior. If you want to know more, join me at my thesis defense on June 3. See you!